Okay, cool. Let's go ahead and get into it. Hello again, everyone. Welcome to From Noise to Signal, Enrichment and Routing with Corelight, Cribble, and Elastic. My name is Desi Gabas-Houston. I'm on the product marketing team over at Cribble. And I am joined by three fabulous presenters. I will have them introduce themselves in just a second. First, a couple of housekeeping items. So everyone's been muted upon entry. But if you do have something to say, please feel free to utilize the chat function here in Zoom. We'll be launching a couple of polls throughout the webinar as well. So we'd love your participation just so we can kind of get a sense for who we have on the phone here and really tailor the conversation to you guys' needs and what you're looking for in a solution. And we'll also be doing a live Q&A toward the end of the session as well. So please use the Q&A button here in Zoom to ask your questions, and we'll be sure to address those toward the end of the call. So without further ado, I would love to have our speakers introduce themselves. Let's start with Corelight.
Hello, everyone. I am Ed Smith. I am head of Alliance Partner Marketing here at Corelight, and very excited to be with you today.
Awesome. Hi, Ed. Jim, you out there?
Hello, my name is Jim Apker. I am with Cribble. I'm on the Technology Alliances team, and I'm in Dallas, Texas this morning.
Love it. Hey, Marvin.
Hello. Hi, everybody. My name is Marvin Ngoma. I'm a senior security specialist here at Elastic, based out of Stockholm in Sweden. Super happy to be here. Thanks.
Awesome.
And I forgot to mention, I'm in Portland, Oregon, on the West Coast. It's very early here, but don't worry, I have my coffee.
I love it. With the Zoom background, we couldn't even see the cup. It's like invisible. It's so funny. I love it. Cool. All righty. You want to go ahead and start it?
All right, so I wanted to start the conversation and take a look at some visibility gaps that our customers are facing. And the first would be novel attacks. A couple examples here in terms of Log4j, SolarWinds, really some challenging vulnerabilities with Log4Shell. This vulnerability really affected virtually every organization on the planet, given the wide range of the software platforms that use that vulnerable Java logging framework. And with Sunburst, this was an attack that affected over 18,000 SolarWinds customers who had downloaded compromised versions of that platform. And these were attacks that were missed by traditional detection systems, IPS, IDS. In the case of Sunburst, we had malware that concealed itself from EDR and other detection technologies. And these threats were massive challenges to security teams globally. And looking at the technology that's out there, every detection-focused vendor failed to identify these zero-day attacks. However, they were ultimately uncovered by curious individuals with the right visibility. And that is to say, access to the right evidence, which I'll be talking a little bit more about in this presentation. A couple other visibility gaps. In terms of legacy IDS and legacy PCAP solutions, looking at IDS solutions, they can be somewhat noisy. IDS alerts are necessary, but by themselves insufficient. And even just looking at the volume of alerts, if you think of an average security operations team getting, let's say 10,000 alerts per day, if you have a SOC team with 10 analysts and you figure 480 minutes in a standard 8-hour shift, that's 1,000 alerts, or really needing to handle 2 alerts every minute, when the reality is that the resolution time is typically 10 minutes or more per alert. There's just not enough time in the day to handle all of the alerts that are coming in, leading to alert fatigue and the inability to keep up with the volume of alerts that are coming in. So why those IDS alerts are necessary and those technologies are necessary just the volume can overwhelm security operation teams when they don't have the right context to handle those alerts. And then in terms of packet capture, when you have a packet capture solution where you're recording everything that's happening on the network, a system like that can be complex and really expensive in terms of storage. And ultimately what that means is if you have a packet capture solution, you may not be able to record very far back in time. So when an incident occurs, if it happened several days or weeks or even months ago, if you don't have that storage available to capture that information and store it long term, that really can be limiting in terms of the information that's available to you. And then the final visibility gap that I wanted to touch on would be unmanaged devices and IoT. And really what I'm talking about here are places where endpoint detection and response, EDR, isn't running or just can't be run. For example, if somebody brings in a laptop from home, or let's say somebody plugs in a Raspberry Pi under their desk into a network port. These are places where you wouldn't have an EDR agent that's running. And even in places where you have EDR running, you still may have gaps. You could have legacy endpoint protection systems that have been bypassed or evaded by an attacker. And Gartner has a solution for this, or a term which we see here on the screen as our representation of what Gartner calls the SOC visibility triad. And the idea is that you have three components that are needed for effective threat detection. First, of course, you have your endpoint detection and response, but the second, and just as important, would be a source of network data or an NDR solution. And then the third component would be a SOC platform that performs analytics and correlation on the data that's provided from both of those sources, such as a SIM or an XDR. And these are the three primary, or the three main components of that SOC visibility triad that gives those security operation teams that visibility that they need. And I think with that, that'll lead us into our first poll question.
Yes, it will. So what I've been hearing you say, Ed, and correct me if I'm wrong, right? Data visibility is crucial. It's actually necessary for you to be able to properly manage your devices and protect them, right? So sounds like there's three crucial pieces to make sure that you have the visibility that you need and minimize gaps. You got network, you need to understand what's happening at the endpoint, and then also be able to centralize those operations. So would love to hear from folks on the call. Where does your team stand in terms of data visibility? Because I think people struggle with one or more of these areas, sometimes all three. Very rarely do I see people already have the visibility that they need. So Amy, if you could go ahead and launch that first poll, would love to hear from the group. Awesome. So if you could
And in
just
terms of, and just a little bit more context for the questions here, with the terms breadth and depth, with an EDR solution, you have really great depth of information. You have an agent running on an endpoint. You get a lot of information, basically seeing everything that's on that endpoint. With the network, that's giving you breadth of visibility for all of the devices on your network. So in the SOC triad model, according to Gartner, network is giving you that breadth of information for all of the devices on the network, while endpoint is giving you that depth of information, being able to see exactly what's happening on those hosts.
Very cool. Awesome. So we've got some answers pouring in. Looks like it's pretty even, to be honest. Most people are looking to better centralized data, but we've got folks out there that need more breadth, more depth. A couple folks that have all the visibility they need, which I applaud you, because like I said, I really hear that. So props to y'all. All righty, we'll go ahead and end the poll so we can keep it moving. All right.
All right. So now I'd like to take a bit and talk about how network detection and response can help solve some of these visibility gaps. First, I wanted to talk about why is the network so important? What is the network giving us that EDR does not? And if you think about the network and attacks that are taking place, if you're an adversary, you really can't evade the network. Practically all attacks that are occurring are going to cross a network at some point. There are probably some exceptions to that, such as Stuxnet, but the vast majority of attacks are going to occur or cross some sort of a network at some point. And in doing so, an attacker is going to create a trail of network evidence. So when you have other defensive technologies that are failing, if you have attacks, novel attacks like Log4j and SolarWinds, you'll still have a trail of network evidence that you can go to detect those attacks, to respond to those attacks, investigate, remediate. And when we're looking at network evidence, this is a source of information that is really immutable. It's a source that of information is really, really difficult to tamper with. So you can think of it in terms of, the network cannot lie. So you could have an endpoint that's been exploited. It can be rendered an unreliable narrator. The network, on the other hand, cannot lie. And while you may have adversaries that are obfuscating their traffic, maybe they're hiding an encryption or imitating legitimate traffic, they're still going to leave behind evidence of those connections. So by monitoring the network, you get a source of data that is an immutable source of truth of what's happening. And with that source of truth, you're getting a set of network evidence that you can use to drive knowledge, to drive efficiency and effectiveness within your security operations teams. So remember that I mentioned IDS alerts. Those are absolutely necessary, but by themselves are insufficient. So by having this network information, collecting that information about your environment, what's happening on the network, that's going to allow you to respond to those alerts, respond to incidents much faster and with more precision. And with this information, you can really drive disruptive defense. So when you understand your environment, you can act quickly and you can disrupt attacks in progress and contain those that have already occurred. So some examples, what do I mean by disruptive defense? I mean things like proactively threat hunting the adversary in your network, automating your response capabilities, building custom network-based detection capabilities that are unique to your organization, having detections that your enemies have no knowledge of. Those are all disruptive defensive capabilities that you can build on the network. And as far as this slide that we're looking at, I think this is a good example of network detection and response platform. In this case, this would be Corelight's Open NDR platform. And what we've done is we've architected our platform around a design pattern that's developed over the past 20 years as we've seen elite cybersecurity defenders use in their environments. This design pattern has typically used open source technologies like Zeek and Suricata, transforming all that network activity into that evidence, into those insights, and then centralizing them into a SIEM like Elastic. And what's great with these open source tools, these are preferred by these elite defenders because they're the gold standard for intrusion detection, network security monitoring. They generate the alerts that are necessary, but also the evidence that's needed to investigate those alerts. And by using the power of the open source community, security teams gain a force multiplication power. They get continuous development from the open source communities. and the content that those communities generate, especially for those novel attacks like Log4j and SolarWinds. And with our platform, we're combining the power of the open source communities with proprietary content. This content comes from Corelight's top security research team, which is led by the inventor of Zeek and Corelight's co-founder, Dr. Vern Paxton. He has a team of a dozen plus elite researchers with backgrounds from firms like Palo Alto and Mandiant, and they're really pushing the boundaries of network analysis and threat detection. And this work has helped Corelight develop really groundbreaking security analytics, which I'll talk a little bit more about in a couple slides. So in terms of Mitre attack coverage, the network is really great at picking up techniques that other controls may have missed. Really useful for covering all of the devices on the network. Again, the breadth of devices that you have on the network. Really good coverage, especially in places where that endpoint agent is not installed, such as unmanaged devices and IoT. And as you can see in this graph, it especially excels in the areas of exfiltration, command and control, and lateral movement. And although it's no single tool can address all of the attack framework, Corelight counters the tactics that other security measures can't, and really excels when the tools that were built to keep out adversaries have failed. So let's take a closer look at what's available with Corelight's command and control collection. With Corelight's command and control, or C2 collection, we have a set of detections and inferences that can help you find C2 activity on your network, detecting things like Cobalt Strike, Metasploit, other commonly used attacker tools. We have the ability to detect over 14 common families of malware that run over HTTP. We can find both known tunneling tools and as well as broad tunneling behaviors, detection for domain generation algorithms that are used for C2 communications, as well as specific detections for Metasploit's command line interface. Now, you might be thinking, all this evidence is great, but what about encrypted traffic? And of course, it is true, most traffic nowadays is encrypted, anywhere from 60 to 80% of it. And there are technologies that can do decryption, but decryption can be very difficult, if not impossible. So that really makes encryption or encrypted traffic a great hiding spot for an attacker. But breaking and inspecting traffic, often not feasible due to security, privacy, legal, performance issues. So for many organizations, decryption is really not a viable option. However, encryption actually creates new actionable evidence that security teams can use. And that evidence can help them understand and analyze what's going on without using decryption. So things like fingerprinting TLS connections, using standards such as JA3 or hash SH, getting visibility into certificate hygiene, monitoring SSL certificates, looking for custom encryption detection. And with our package, we also offer a dozen plus insights into potential risk, looking for things like SSH connections with file transfers, or keystroke activity, DNS over HTTP, insights into RDP authentication that's being used. So even without breaking and inspecting that traffic, still a lot of useful insights and information that you can gain through our encrypted traffic collection. So how does this fit into your environment? With Corelight sensors, we can get these up and running in about 15 minutes. Each one of our sensors supports the full platform of analytics tied to evidence that I've presented in this session. We can deploy both on-prem and in the cloud. So when we talk about network traffic, when I'm talking about network traffic, this isn't just traffic that's crossing your on-premise networks, but also traffic in the cloud. We can deploy in AWS, Azure, and Google Cloud and give you that robust network detection and response capabilities wherever they're needed. So all of this information, all of this evidence, really useful for detection, for incident response, for threat hunting. Now it's a matter of getting that evidence to the right places, enriching that evidence and routing it to the right destinations. And to talk about that, I am going to hand the mic over to Jim, who will walk you through Cribble's platform. Thank you.
Thanks much, Ed. Good stuff. I will start with a quick high-level overview of Cribble for those that maybe aren't familiar with what it is that we do, but Cribble offers choice. When we think about what we offer the customers, it's the ability ultimately to gain control over their data, allowing them to collect, route, and optimize that data into any format, sending that data to any one or more destinations. We can be deployed in minutes as either a SaaS, on-prem, or even hybrid solution. And like it says at the bottom, simply put, we optimize the process for connecting any of your data sources, formatting in any of the schemas of your choosing, delivering to any one or more destinations in the environment. Next slide. So Cribble exists largely because data transit, has been a problem and continues to be a problem moving forward, in large part, not just because we see data proliferation rates at 25%, compounded annual growth rates, but because this data is varying in nature, and we're seeing it being created from more and more sources over time. More data, more problems essentially means that we're trying to transit this data over decentralized legacy infrastructures, typically consisting of collectors, aggregators, forwarders, things like syslog servers. Very fragmented environment, very tough to move this data over the existing infrastructure. And then on top of that, we're having to deliver this data oftentimes to more than one destination, in large part because of retention, compliance, but also from a threat hunting and investigation perspective. So again, moving this data typically to one or more destinations involving systems of analysis, oftentimes low-cost object storage, or systems of record on top of that. Next slide. I think this is where Desi's going to hit us up with another poll question.
I am. So Jim, you mentioned a couple of things that I'll just recap real quick while Amy launches poll number 2. So I'm going to talk about data transit, right? There are some real problems associated with just the massive growth of data. So you mentioned data proliferation, right? Either too much data or too many types of data, decentralization of that data, and just struggling to comply with retention requirements or other regulatory requirements. So I'd love to understand which pains folks on the phone are experiencing in their teams today. And I see answers flowing in. It looks like most people are struggling with data proliferation at the moment, to the tune of about 70%. But we've got folks struggling with decentralization of the data and compliance, as well as a couple other things which I'm curious about. So if you voted other, feel free to type in the chat what that is, because I always feel like new data pains are coming up every day.
Quick note too, regarding this proliferation issue, we don't see it just from the customer side of the house. We also see it from the vendor side of the house, especially with me being on the alliances side. Data ingest, right, continues to be a problem. And we see this day in, day out. Customers have teams of people assigned to data ingest, right? So we're oftentimes using multiple consoles and multiple locations to onboard things just like syslog, right? It's a genuine problem. And what we absolutely need is what Cribble's here to solve today. And that's just that centralized console, that centralized, efficient, modern logging infrastructure to address these problems that we see day in, day out.
Awesome. Cool. I will go ahead and move on.
Very good. So how does one go about deploying Cribble? So Cribble maintains from the stream side of this house a leader node, which acts as our centralized UI. It acts as centralized config. That leader node is the control plane. It can exist in Cribble Cloud, your cloud, it can exist on-prem, can exist anywhere. And then we have the devices that do the heavy lifting, these workers or worker groups, if you will. Best practice would suggest that we deploy these worker groups as close to the data as we can. So we may have Corelight deployed, in the cloud, may have Corelight deployed on-prem, but these worker groups, anywhere the data exists, and then these worker groups will then send that data to one or more destinations. Slide. So again, Cribble in the middle is kind of the theme here. And what I mean by that is we're trying to close these visibility gaps that exist in the network, especially when you're relying on things, cybersecurity frameworks like Mitre attack, right? It's all about quantitatively, forward-looking wise, closing those visibility gaps. So we'll have lots of different data sources. We can replace that syslog infrastructure, Kafka. We're going to receive EDR data, maybe alongside this NDR data that we're seeing from Corelight, but we've got all these data sources. We're going to centralize that data from the source perspective. The stream will route, collect, reduce, transform that data into any one or more destinations. So today we're going to send that data to Elastic, and Marvin's going to show us what that looks like. Optionally, we can also send copies of some of that data or all of that data to a data lake of your choosing for long-term, low-cost storage. And then as needed, maybe 2-3 years down the line, we have an investigative reason to go back and look at that data. If it is timed out of our system of analysis, our SIM, maybe Elastic, we can replay that data right through Cribble Stream to resend that data, to thaw that data, and push that back into the destination for analysis. Let me talk about use cases real quick. Go back to that previous slide of Desi real quick. Why would we put Cribble in the middle? So number one, probably use case that we see, oftentimes is when a customer is maybe moving from, let's say, Elastic on-prem to Elastic Cloud, or maybe when we're moving from an existing SIM tool to Elastic, it makes a ton of sense to actually put Cribble in the middle to jointly deliver data to both of those solutions to ease that transition from one vendor to the next. And then obviously we can also fork copies of that data into existing or new platforms, not just to the system of analysis, but like mentioned earlier, also to that data lake or that object store. Next slide. So what does the integration look like? We mentioned earlier that we can spin this thing up in the matter of just a few minutes. Specific to Corelight, what we do is we spin up an HTTP event collector, open up a socket to listen for inbound data from Corelight. We'll generate a token, give that token to Corelight. They're going to use that token then to send that data into the Cribble Stream workers. At the same time, we're going to create that Elasticsearch tile on the right-hand side there, configure that to send data into Elastic. We're going to connect our source, the event collector, to that Elasticsearch destination with a route. And then within that route, we'll create a pipeline. And we're going to take a look at that here shortly. But that pipeline is where the heavy lifting gets done. That's where we transform, we reformat. In today's session, we're going to do a lot of enrichment, asset and threat intel type of enrichment before we send that alerts and that metadata to Elastic. So what we end up with are a bunch of sources on the left-hand side, multiple pipelines, formatting that data as we see fit. Importantly, normalizing that data, looking at common schemas regarding assets or identity, like normalizing interesting fields if we need to, and then passing all of those data sources back into Elastic. Next slide. So we'll focus on enrichment today via lookup files, and within our pipeline, we'll take a look at how we execute these lookup files. But quick note, the lookup context can be maintained in something like a Redis external database, or we can maintain them locally. And what we'll do today is take a look at CMDB info, right? So as we see data being populated from a CMDB perspective, we're going to enrich that data. And this, again, becomes important. Maybe we have an EDR in play where we can actually capture that asset information. We can populate maybe a Redis database, with that asset information locally, and then we can apply that asset information across all of our different data sources such that we have a clean, cohesive view into the asset or identity space before we send that data into Elastic. And that's done in real time, so we're not having to deal with time-sensitive lookups looking backwards. I also include in many of the packs that I write, and in this demo, the Majestic Million lookup file. And it's a collection of the top 1,000,000 domains, which is maybe a bit too much for most reasons, but that's how they publish it. And what we can do is, with that Majestic Million, we can add context to things like maybe DNS or HTTP to provide some risk-relevant context in terms of whether this is a domain that's maybe safe to ignore, right? It's maybe not anomalous, so we can use that to essentially, potentially, cut down on some of these heavy data sources like DNS by a factor of 50, 60%. And then along the bottom there, certainly you can maintain multiple threat intel collection types with different indicators within those. It could be IP addresses, HTTP email, domains, certificates, JA3 hashes, really anything that you'd like. So you can maintain those externally, push those into Cribble. You can have Cribble pull those on a recurring basis, into Cribble stream maybe once an hour or so, and we'll apply that in real time against all of your data sources, not just Corelight, but everything that passes through Cribble. Next slide. Take a look here real quick. This is fairly common for the industry. You'll notice that I prepended all of my column names with asset underscore, and that's going to come back here in just a little bit. This is just a quick example of what maybe one of these asset relevant lookup files looks like. So we'll key off asset IP. It's going to have a different name in the demo that we'll show you here. But when we see that IP address, we're going to enrich it with all of those fields that we see there. We can slim that down if we don't want all of the fields, but again, you're going to see what that looks like from a normalized perspective, forward-looking wise. Next slide. So this is the pipeline that I mentioned. So once we connect our Corelight source to our Elastic destination from a top-down processing perspective, first we're going to parse the data, and then lastly, when we're done operating on the data, we'll stitch that stuff back together, serialize it, send it off to Elastic. In the middle there, you'll see that, oops, sorry about that. You'll see that the threat intel section, I've got a group that allows me to apply each of those threat intel sources against that data. Looking down, we can see that next we're going to normalize with quick asset lookups. Same thing with identity. And then, if we do need to further format that data, we can just simply add more functions to enrich that data, format that data, change the nature of the data, slim it down before passing on to Elastic. Next slide. And this is really powerful, right? So this is the ability to either use sample data or capture data in real time right before you go to prod, to essentially look at the inbound, apply your pipeline changes, and then see in real time what each of those changes by you on the outbound. You can also quantitatively metric what you're seeing in terms of field reductions, overall event size reductions. And in this case, all we're really showing off is the effects of the enrichments via the lookups. So you'll see that based on the original IP address that's pulled from the Corelight data, we're going to apply two things. In this case, we're going to apply asset relevant context. So everything's nice and clean with asset underscore. And then towards the bottom there, we happen to see that there was a threat intel match. So again, you can control the context in terms of what's in that threat intel lookup file. In this case, I've got a description, the original indicator, and then also the weight. So again, from a risk prioritization perspective, from visualizing, from easing the burden of correlation across multiple data sources, all of this context serves a very important purpose in terms of operationalizing all of these data sources within the ecosystem. Next slide. So what we now have is a diverse, and normalized collection of data sources, including this NDR data from Corelight, with Cribble Stream as the modern collector or receiver, all managed from a single Cribble console, all being sent to Elastic. It's now time to hand this over to Marvin with Elastic to see how they operationalize all these data sources.
Awesome. And I'll go ahead and stop sharing so you can grab the screen, Marvin.
Awesome. Thank you. Thanks a lot. All right. Just confirm you can see my slides.
I can. Looks great.
Awesome. All right. Hi, everybody. Again, my name is Marvin from Elastic. And in this part of the webinar, basically, I'll just give you an overview of how Elastic Security basically operationalizes everything that Ed and Jim have shown us today. Our mission at Elastic Security is basically simple on paper, but not that simple in reality. And that is to protect the world's data from attack. And we've already seen from the poor results that we're talking gazillions of data, right? And a lot of us are facing a lot of challenges in terms of how to manage this data, how to identify the data that's really relevant from a risk point of view, talking about security with regard to organizations. At Elastic, we realize that organizations, first of all, need to ingest nearly everything. So again, this is where you need to be a bit deliberate in terms of, what data do you need for your security use cases. But ideally, what our platform does is to give you that possibility to ingest all the data that you need for your use cases. And then also you need to fetch and analyze that data, right? We're talking Elastic, and it's Elasticsearch that powers a lot of the solutions from Elastic. And Elasticsearch has been written in such a way that it allows you to store that data in a very search efficient manner, allowing you to have that speed and also good experience in terms of fetching and analyzing your data. And then once you store that data, you really want to get out that information from your data, right? And this is where the visualization and exploration capability into that data comes in. And Elastic basically gives you Kibana, as I'll show in the demo, in terms of really getting those insights from your data. All right, so expanding on the previous slide, we see that what we've done over the years at Elastic is basically to create a curated solution. Right? So this is what we're calling Elastic Security, but basically it's just an augmentation of endpoint security capability, SIEM capability, and cloud security capability. Ed showed us in the beginning to say, Corelight are really good at doing network detection and response, and then Cribl, come in and do that enrichment of the data. They also give us that routing capability. But then when that data comes into Elastic, we need to find a way in which we can actually write interesting correlations on this data. So basically what we're looking at is giving you that in-depth focus, visibility onto your endpoints. But we know that endpoints don't exist in isolation, right? They're connected to other endpoints, to other systems. There's users interacting with these endpoints. So there's a lot of telemetry on the endpoint, but also in the broader environment of organizations, right? And that's where the SIEM and security analytic capability comes in. And then when we talk about cloud, cloud is basically, it's a technology. We've been talking cloud is the future for a long time. But when you look at the current state today, a lot of organizations are adopting cloud. It doesn't matter whether it's public cloud or private cloud, but it's basically that mindset shift in terms of how we are consuming technology today. And with the advent of cloud security, basically, there's unique security challenges that it brings. And Elastic is really trying to dive into that space by giving you that cloud native security capability that you can make use of just to keep track of your security posture in that sense. So in a nutshell, Elastic Security is looking at unifying SIEM capability, that's so integration capability within the platform, the XDR endpoint, and cloud security capability. So let's take a couple of steps back. I know Ed touched a bit on this in his introduction, basically where we're looking at the different tactics and techniques from a Mitre point of view. It doesn't really matter which framework you're looking at. Generally speaking, attackers go through a couple of steps, right? So it usually starts with information gathering. And then once they get a very good feel of what type of target they have or victim they're going after, they look for having that foothold into their target's environment, right? Doing that initial access. And then there's a couple of steps, but at the end of it all, what the attacker is trying to do is basically, first of all, establish, some form of communication so they can issue commands into whatever compromised assets that are present in your environment, and then execute on their objectives. Usually it's things like data destruction, data exfiltration. Again, it's dependent on what they really want to do. So we've seen the introduction again from Corelight and Cribl, and now we've seen the introduction from Elastic. How do the three solutions fit into this anatomy of an attack, right? So with the reconnaissance, we need to collect the relevant data that's going to give us insights in terms of, are there any scans that are happening on our network, right? Is there any indication of someone probing for information on our assets or even on our people, right? And this is where you can use Elastic basically to collect data from interesting data sources. At the network level, you can use Corelight. And we've just seen from Jim's segment just before I started there's a lot of enrichment capability that Cribble brings into the story in terms of just giving us that metadata around the users in our environment, around the hosts, as well as any enrichment data that we can collect. And then when you look at that initial foothold, that initial access into the network, right? We need evidence. Most times it's at the network level, but again, looking at what Elastic is doing with endpoint security capabilities, we still get the telemetry at an endpoint level in terms of what's really happening at the process level, at the network level. But again, you can still use Corelight, and then Cribble gives us that enrichment in terms of really getting that metadata around what's really happening from an initial access point of view. And then that speaks into the command and control as well, right? Where we're looking for that evidence to really complete the story in terms of, are we observing any command and control? And then also, is there objectives that the attacker is actually executing in our environment? All right, then. So Elastic, again, allows you to operationalize this data from Corelight and Cribble, and we'll see how in a bit through the demo. But one of the key things that Elastic really allows, looking at data coming from the likes of Corelight, the likes of Cribble, and many other data sources out there is, we're really good at doing this cross correlation. So you can bring in, Elastic allows you to bring in so much data into the platform. It can be data from basically any data source. We're able to ingest that data, do normalization on that data, and then give you the possibility to do this analytic that gives you insights from a security point of view. So talking about Elastic Security, we're looking at that unified prevention and detection capability, right? Where we're facilitating that real-time detection and protection by really applying actionable analytics on data, right? When we talk about actionable analytics on the data, basically we're talking about the detections, and I'll walk you through that in a bit. The other thing that we allow you to do is, we've been talking visibility on this webinar, right? And visibility is a realistic challenge. It's a big challenge for a lot of us. The platform really gives you the possibility to have that real-time holistic visibility, whether you're on-prem, whether you're in the cloud, or whether you're a hybrid environment, right? We've got capabilities such as that cross-cluster search capability, where you can have a centralized cluster and then multiple clusters, maybe one on-prem, another one in the cloud, and then you can have a central place where you can run these detections and then basically just have a continuous monitoring of your environments. And then lastly, but not the least, one of the things that we want to do is reduce attacker dwell time, right? Really to minimize or even avoid any damages from a cybersecurity point of view. And how we do that basically is, the platform ingests data. You can enrich that data, as Jim has shown us. That basically allows you to really do more proactive stuff, such as threat hunting, where you go looking for any indicators of compromise in your data sets as well. At this point, I'll just pivot into the solution so we can see how exactly Elastic looks like. So when you go in the solution itself, one of the things we've done is we've created what we call the default dashboards, right? So these are pre-built dashboards that basically just give you a bit of an insight in terms of what's really going on within your environment, right? So if I come into the overview page, basically I can see the alert trend over the last 30 days. You can set a default of the last 24 hours just to make you understand really what's going on within your environment. And then also in relation to that, one of the things I can look into is how much data have I received and where is it coming from, right? Just basically having a bit of an understanding in terms of what data am I receiving. And that speaks into the threat intelligence as well, right? So Elastic allows you to collect both commercial threat intelligence as well as the open source, the likes of the Mitre, the WCH of this world. And also, you can also bring in your own internal threat intelligence, because again, Elastic is hugely API driven. So now that we've gotten this data, what can we do with the data, right? And this is where, the rules come in, right? So to make it easy to get up and running, Elastic ships with over 700 rules that are mapped to the Mitre attack framework, right? So we've been talking about the visibility challenge, and we've seen some interesting results from the poll that this is doing. So one of the things you can do basically, like I like to advise a lot of organizations, is start out by identifying the critical aspects within your environment, you can start from there, right? And then collecting relevant data from them. Now, once you do that, once that data comes into Elastic, it's really easy to find relevant rules that you can use for the type of data that you're bringing in, right? So you can search on tags based on log source type. So for example, if I say Windows, it's going to show me all the rules that are really relevant to the Windows assets within my environment. And then most of these rules, like I said, map to the Mitre attack framework, right? So essentially what you're getting an insight into is, what tactics are involved in some of the alerting you'll be getting from these rules, as well as, some of the techniques that are being observed in your data sets. The next thing that I want to talk about is basically that endpoint capability, right? So if within the solution, again, I go into what we call fleet. So what I did for this demo basically is I spun up a Linux machine and I enabled the Elastic endpoint security capability on that particular endpoint. Now, what I just want to show you is, first of all, the amount of telemetry that you can collect on your endpoints, right? So if I come to here, just look at the settings. So this is a Linux instance, and one of the things that I'm doing on here is basically collecting file events, network events, and process events, right? For those of you that are familiar with Linux, you know that a lot of artifacts on Linux are viewed as a file, right? So basically, using the agent that's running on Linux, you can basically get a lot of this telemetry into Elastic. Talking about that depth that Ed mentioned earlier on. And then in addition to that, one of the things you notice in this policy is basically I've enabled a protection level that's called prevent. And this is where we're very proactive in stopping things before they actually go any further. So as soon as we identify that certain aspects on your endpoints are malicious, we stop them and then give you an alerting based off of that. And this covers a broad range of threats on the endpoint itself. We're talking memory threat protection, we're talking malicious behavior protection, and that also extends into the ransomware protections themselves, right? So giving you that pre-execution and post-execution prevention in that sense. All right, then. So we're talking Corelight, Cribble, and Elastic. So let's look at back into the security solution. What can we do with data that's coming from Zik? What can we do with data that we're seeing, say, for example, on the endpoints themselves? Now, Elastic gives you a capability that's called timeline. Now, timeline is a workspace, right? So you can pretty much write queries, specific queries through dragging and dropping interesting fields. You can also do correlations, right? Now, let me just spend a bit of time on the correlations themselves. Let me just go back to the rules again. So going back to those default rules. So remember I said we've got over 700 rules mapped to the Mitre attack framework. Two other things that you can do with these rules is, first of all, you can duplicate the rule and then add in your own logic. So for example, things like exception handling, right? Maybe there's certain aspects that you want to exclude from these rule executions, right? But then in addition to that, one of the things Elastic allows you to do is write your own query rule. Now, as of 8.6, which is our current version, Elastic allows you to write rules across these 6 rule types. The first one is the custom query rule type, where you just use the classic Kibana query language or Lucene to actually write interesting queries that give you insights into patterns that could be an indication of compromise. The next category is that of machine learning. Now we're talking collecting a lot of big data, right? What can we do with the data that we're collecting in Elastic from a security point of view? So you can actually create machine learning jobs that run on this data. You can choose a criteria, and then over time, Elastic gives you insights into the anomaly detections around this data. It can be anything from process activity, it can be user activity, it can be network activity. So that rich telemetry that we're getting from Corelight, you can actually use a lot of the fields in that data really to create these machine learning jobs. The next one is that of really aggregating some of that data, right? So this is where you write aggregate queries, and then you're looking at certain threshold values in some of the values in those fields in the data. A classic example there is a brute force attack, right? So where you say maybe if there's 3 failed login attempts and then followed by a certain event, you really want to be alerted on that. And similarly, that can be used on the event correlation. Now, this is one of my favorite rule types because it really brings the power of Elastic that I mentioned about where you can do cross-data correlation, right? And now I'll write a query in a bit where you can see some results in terms of endpoint data, as well as the data that we're receiving from Zik, essentially Corelight. The next rule type is that of indicator match. Now, indicator match basically is when we receive that threat intelligence in Elastic, we really want to see if there's any matches in that threat intel data against some artifacts within our data set. Talking about IP reputations, we're talking about file hash reputation, we're talking about domain reputations, et cetera, right? So if there is a match, essentially what we want is to be alerted on that. And lastly, but not the least, we're talking about the new TAMES rule type. Now, this one is interesting because when you're receiving telemetry from the likes of Corelight, Zik, Suricata, right? There's a lot of network telemetry in there. So say you are a bank and you do Swift payments, just as an example, right? Swift is very strict in terms of really isolating the Swift network from the rest of your network. So you could use the new TAMES rule basically to write a rule that allows you to look out for any IPs that may come up that are not allowed to be seen on your network, right? So I like to think of this one as a mini machine learning type of rule type, but it's just good to know that this rule type is supported. All right, so we're talking correlation. So I mentioned timeline earlier on. What can we do with timeline, right? How can we action this data? So it's basically using that EQL, the event query language that I spoke about. So I'm just going to write a simple query and hopefully get some results in terms of, Corelight and Elastic data, right? So I'll write a sequence. Sequencing is something that's supported within EQL. And what I'll say is I want to look for network data where the network protocol is basically DNS, right? And I want the DNS equation name to be anything from, let's say, I'll say let's encrypt, right? So basically, we're looking out for any DNS traffic that's looking to use SSL certificates that are from free websites. So let's encrypt is one of them. I can include just one more, maybe free SSL.org, and then I'll close that. And then in this same sequence, one of the things I want to do is to say there's a concept that's called living off the land. So essentially, this is when attackers get a foothold on our endpoints, and they're trying to exfiltrate data from the endpoints, right, by using certain services that we trust that run on our endpoints, right? So in this example, I'll just use one, basically, just to keep it simple. So I'll say process executable. Executable is, and then, all right. I think I have the query written somewhere. Let me just copy and paste it in the interest of time. All right, so that's basically my query here. And I think this is supposed to be like this. All right, just give me one moment, please. All right, perfect. So this is my query then. And then I can specify basically where I want this query to run on. And this is where I specify the indices where Corelight writes its data into, right? So basically this query is going to run. And then I specify the time period in which I want the data sets to be queried, right? So if I expand this to say the last 7 days, I get a lot of information around any network activity that's tagged as DNS, and then it's also querying these destination domains. And then the process is a process that we trust on our Linux machine, right? Using this, I can then discover what users are behind these activities, what assets are involved in this, and then looking at, what Jim presented earlier on, I can get metadata around, for example, if there's a very important user that I'm seeing that's making these connections, or if there's a certain asset that's really important from within my environment, I can really zero in on that particular asset. Now, recall that when we looked at Fleet and Agent, there was a Linux machine that I was looking into. So Elastic pretty much allows you to drill into some of these fields, right? Some of these artifacts. So for example, I could say, investigate this particular endpoint in timeline, it will be added there. And then say this is a critical user in my environment. I can zero in on what a particular user was doing within my environment and just try to understand, what activities have they been doing on the network. So I could use telemetry from the endpoint itself. As you can see here, the event.category, its process, there's registry activity. All this is telemetry that we're collecting using the agent that's running on the endpoint. If I want, I could get specific and drill down on network activities that are coming from Zeek or even Corelight itself. So cutting to the chase there, one other thing I really want to show you is the visualization capabilities of Elastic, right? In collaboration with data that we're receiving from Corelight. So for example, I created this dashboard. Now, by default, the Zeek integration also comes with an out-of-the-box dashboard that just gives you insight in terms of really what's been going on within your environment, right? So this is just one example dashboard. I'm looking at what are the top DNS domains that Zeek is basically giving me insight into, how the traffic breakdown, right, in terms of network traffic direction, as well as the network protocol that's involved in that type of traffic. And then Zeek is really good at breaking down the data into different categories, right? So I can check, depending on the time period that I want to look into, what type of data is really constituting most of the data that I'm getting from Zeek. Now, just looking at time, so I'll give it back to you, Desi. Thanks a lot.
Awesome. Thank you so much, Marvin. All right, Amy, if we could go ahead and launch poll number 4, just in the interest of time. I think what we all saw here, which is amazing, is that, we get that full data visibility from Corelight, right? Real visibility into our network. We're able to centralize the Corelight data as well as other data sources via Cribble, and send that data over to Elastic to be able to operationalize that data. It's going to do a couple of things for you. Mainly, you'll get that full visibility across all your systems. Your teams are going to get resources back, including time, right? So they can focus on what really matters and not always time, figuring out how to operationalize their data or how to data pipeline, right? And then all of that is going to come together to help accelerate detection and response, excuse me, which helps control budget and ensure security of your company. So we'd love to understand which solution you guys are interested in learning more about. I see we've got some interest for all 3 vendors, and be aware that you can select multiple. So we'd love to hear from you. All righty, thank you. And then with that, I know just in the interest of time, we had a couple of questions come in. We will follow up with y'all after the webinar. We've got some questions about EQL, which I'll probably pass off to you, Marvin, and then some licensing questions as well, which we'll be sure to follow up on. Great. Well, thanks everyone for joining. We will go ahead and end the poll and also end the webinar. This will be available on demand for you guys to see the presentation and watch through it again if you would like. So we will be sure to follow up with that information, and we will see you at the next one. Thank you for coming.